All right, hello again to Mr. D's math class. Good afternoon, students. This time, in our lessons, this is called 3.2, using models to multiply fractions. More specifically, it's using area models to multiply fractions. So I'm going to show you how to model, and then I'm going to show you the math part. Well, the math part is really very simple here, unlike, it's like adding and subtracting fractions where you need a common denominator. In this case, you don't need a common denominator for these. You really just multiplying the numerators and multiplying the denominators. So this is totally different from adding and subtracting fractions. So 1 times 1 and 5 times 3 is 15. So what is 1/5 of 1/3? It's 1/15. So now I'm going to show you how is this going to look like as a model. Well, they want you to get used to looking at this as a rectangle or an area model. Okay, so the first thing I'm going to do is I'm going to model 1/5 is as a length, and then model 1/3 as a width. Because when you multiply this, the area model really is length times width. That's what they're trying to get at. So how do you model 1/5 in this case? So I'm going to model this actually in two ways. One is my way, which is actually showing double shading, and the other one is the way the textbook does it. Okay, so if I wanted to model 1/5, I'm going to divide this entire length into 5 equal pieces. That means I'm just going to draw 4 lines in them so that they are divided into 1, 2, 3, 4, 5. So that is our denominator, dividing it into 5 pieces lengthwise. So now how do you model then 1/5? Well, what I like to do is I like to shade 1/5 in one direction. Notice it's slanting in this direction. So this is my 1/5. Okay. You could even cover this if you like, and can show you that 1/5 of this 1, 2, 3, 4, 5 pieces has been shaded. Okay, so now what I'm going to do is I'm going to divide this width this way now, horizontally, into thirds. So I'm just going to draw 2 lines here, which is already actually on a rule number, ruled line. And now I'm going to shade in what 1/3 might be, which I could shade up here or in the middle or down here if I want to, but I'm going to stick with the top one, and I'm just going to shade 1/3. Notice I'm shading it in the other direction, the slanted direction in the other way. And so if you cover this, now you're going to see that if you're looking at it sideways, horizontally, you'll see that 1/3 is actually shaded out of the 3. Okay, and so what I try to show is how many of these blocks or these squares are actually double shaded. Well, here you are. You have one of them that's double shaded, and that'll give us 1 out of, well, there's 15 pieces here altogether. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 1 out of 15 is double shaded, and that is really what the answer we were supposed to get here. Okay, now the textbook does it slightly different. I guess it's hard for them to show double shading, so what they do is they start off with also dividing into 5 pieces like so, and then they'll just cover this for a second, and they're going to shade in just 1/5, and so there's your 1/5. Okay, and then they turn it sideways. I'm going to attempt to turn this sideways into my camera. Now that we're going to model 1/3. Well, how do you model 1/3 there? Well, it looks like it's already shaded, except we're going to divide this into 3 pieces, and if you look at it just this sideways, you notice that only 1/3 is shaded out of the 3, and so that's where we get our 1/3 from. I don't know which one you like better. I guess my style, is a little bit messier, but it does show, one model at a time. and it shows a double shading. But this is the way the textbook, they only shade one piece here, and that is equal to only 1/5 of the entire 15 pieces over here. Okay, and this is the textbook way of doing it. They don't double shade anything. They just shade that one piece and for their answer. The thing about doing it this way, it's almost like you almost have to know the answer before you even get to shading it. So what I'm going to do now, I'm going to show another example where we have to shade in more than just one. Okay, so how about we try this one, 1/2 times 2/5. Okay, let's try that. So now what I'm going to do is I'm going to keep this 1/2, this first fraction as the length. Oops, focus please. And so now I'm going to try to model this first before I do the math. Okay, so here is my rectangle again. I'm going to try to do this the textbook way, just to keep it neat. I'm going to look at this length up here, and I'm just going to cut this in half because that's the denominator that we're talking about. Okay, so I'm going to cut it in half, like so. And then from here, you see, again, you also have to know what to do with the second fraction already. So you have sideways, from the length, from the width-wise, you're going to have to divide this into 5 pieces. So 1, 2, 3, 4. So now we have fifths on this side, and we have halves on this side. I'm not drawing a numerator yet, but if we wanted to shade in 1/2 of this, then I guess we'll have to shade in like so. But we can't just shade that because that's just the length. We want to shade in 2/5 of this width, so we're going to have to shade in 2 of these. Okay, again, I should turn this sideways. Here's my fifths, but then now I have to actually shade in not just 1 but 2, like so. Okay, so now we have 2/5 shaded from this width, and we also have 1/2 shaded of this half length. And so what is our answer for this? We seem to have 2 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 out of 10 are shaded. So our answer here is 2/10. And I wonder if that's what we're going to get when we multiply this mathematically. I hope so. Just multiply numerators, multiply denominators, and we get 2/10. I'm not going to worry yet about reducing this, but I might have a separate video on how to show that. It's called reducing fractions using greatest common factor. But if we wanted to, we really can reduce this easily because, as you can see, both 2 and 10 are even numbers, and you know that even numbers can at least be divided by 2, and so 2 divided by 2 on the top is 1, 10 divided by 2 on the bottom is 1/5. And that's our answer. Okay? So, I hope that does help with using models to multiply fractions, okay? And a little bit of reducing here and there. I will do, my next video will be on reducing fractions using greatest common factors. So, if you have any questions, just put on a comment below and I will read it and see if I can answer you back. Okay, so there you go. There's 2 ways to do this. There's the double shading way. If you're going to do the double shading way, at least highlight the areas of the squares that are double shaded. Okay, so now why don't we try that here? Double shading way. Okay, length times width. So if I wanted 1/2 of this length, I guess I'm gonna shade in an entire 1/2. And if I wanted to model 2/5 over here, I guess I can divide this into 5 pieces. 1, 2, 3, 4. And so now there are, you know, widthwise, there are 1, 2, 3, 4, 5. And now I'm going to shade in 2 of these. In this direction, there you go, I shaded 2 of them, but how many are double shaded? Well, I'm going to highlight that here. I suppose I should have pointed that out to my students so that they can show me and highlight what is double shaded, and it's right here. So if you're doing it the double shaded way, I think it helps for you to highlight which ones are double shaded. Okay, and again our answer here is 2/10 that are double shaded. Okay, and of course, yes, 2/10 does reduce to 1/5. Okay, so thanks for watching, and I hope this video does help help you with your assignments, etc. And I wish you the best of luck. Have a good day.